IQM is the European leader for superconducting quantum computers. Our mission is to build the most powerful quantum computers for the well-being of humankind, now and in the future. What we are doing is, we are building quantum computers that will revolutionize the world in many aspects: fundamental science, industry and societal aspects. At the moment, we are focusing on building quantum computers that can be installed in supercomputing or big research centers. With this, we are helping to educate the next generation of talents, but also to do fundamental research. In the next step, we will reach quantum advantage. With quantum advantage, I mean that quantum computers will be more powerful than any supercomputer in the world. This is the point where the field really will feel commercial traction, and we will solve the most pressing business problems of these days. So on the technology side, the challenge is actually to build a large-scale quantum computer that does useful things. And here in IQM, actually we are innovative at different layers of abstraction. So on the highest layer, we are building application-specific devices, and in this way we become very, very hardware efficient. And on the, let's say, algorithmic layer in between, we are using a novel approach which is called digital analog quantum computing, which in a sense combines the best of two worlds: the world of digital quantum computing and the world of analog quantum computing, which some people call annealing. And we are just taking the best concepts of these two worlds and combine this.
For us, it's important to understand our customers' test requirements and test challenges. And here IQM is a unique example, where a close cooperation is needed to follow the fast-moving quantum industry.
Well, building a quantum computing startup requires many things, especially if you work in the hardware sector as we are doing. So we are really building the hardware for quantum computing. This means you need to have some kind of IP or know-how on how to fabricate the devices, how to assemble everything together, and this is what has been developed over the decades here in Finland. In addition to this, we have access to a world-class infrastructure here. So again, for superconducting quantum computers, you need low temperatures and you need to fabricate the processors. So many of our great ideas come from the daily brainstorming sessions that we have with the technical team, both here in Finland and in Germany, where we are working hand in hand together. And this is our idea on how to grow in the future as well, working with the best people in the best places worldwide.
So typically we determine for our QPU chip things such as the scattering parameters and decoherence mechanisms and crosstalk and related microwave measurements. And we also need to characterize our microwave environment, such as all the cabling and equipment connected to the fridge itself, and the lab environment, noise from power supplies, etc. We also need to characterize our measurement and control equipment pretty carefully. Parameters such as nonlinearity, drift and phase noise, and also long-term drift. We also do calibration regularly, so all of these we correct for environmental factors such as temperature and environmental traffic. We wish to basically freeze the equipment used at each setup, so that we can rely on the standardized methodology used with these same equipment every time. We also do some cross-checking from historical measurements and measurements from different setups.
We are proud to be a supplier to IQM. We provide world-class test and measurement equipment, power supplies, oscilloscopes, signal and spectrum analyzers, RF sources, among others.
So we need to determine from our control electronics things such as time alignment of the control pulses and latencies, and things like signal to noise ratio, not just wideband noise but also spurs, And also one very relative parameter is phase noise of our signal sources and also long-term drift. The RTA oscilloscope is an easy-to-use tool for checking hands-on measurements such as pulse shapes, their alignment, and triggers and clocks.
What makes us unique in IQM is actually that we are working on both sides at the same time, and what we are doing is we are mapping the software in a very efficient way onto the hardware. So in this sense we are using the hardware in the most efficient way, and this is what we call co-design. So only if these two worlds are working hand in hand together we can really find an optimal solution. What this means in more technical detail is that we are building application-specific quantum computers.
The benefits include our local sales and application support close to IQM headquarters in Espoo, Finland. In addition, our service teams ensure that the high-quality test equipment are calibrated and accurate. In addition, we have direct access to our development teams in Munich, Germany. All this guarantees that we have a great base for the future collaboration.